Hello, hi. So today I have picked one more problem from LeetCode. So the problem statement is task scheduler. So let's read the problem first, then I will discuss the approach and solution. Let's jump into the problem first. Okay. So problem statement is when you can find it the problem from you can search the Google search task scheduler, then you get the LeetCode link and you can attempt that from there. Okay, so the problem statement is you are given an array of a CPU task, each labeled with the letter from A to Z and a number n. Each CPU interval can be idle or allow completion of one task. Task can be completed in any order, but there is constraint. There has to be a gap at least n intervals between two tasks with the same label, and return the minimum number of CPU interval required to complete all tasks. So if you see the first example, same task are repeated with the label A, B, B, B means three times A and three times B, and N is the gap which we need to ensure while attempting same number of task after just after completing before. Okay, so if you see the explanation, possible sequence. One possible sequence is attempt at t is equal to 1 task A. Then we can't attempt again task A as per our problem statement condition. We can attempt only when time interval between the two same tasks should be at least n. Okay, so that's why we can attempt B. Okay, so at time is equal to 2 we attempted V, then we have only one two task. If you see task and task B, then we don't have any more any other task. So and we can't reattempt the task A because it required if you see if it required at least an intervals, mean at least two interval within the time. Okay, so if you see here's time is equal to 3 and here is time is equal to 1, right? So if you see the difference, there is less than the n which is 2, so we can't attempt. Then we need to keep it ideal. So CP in this time duration CPU will be ideal. Then attempt B, similarly then attempt B, attempt A, V, and ideal A and V. This is the way entire task will be completed, and once the entire task will be completed, we need to return the time, but we need to minimize it. Okay, so if you there are three examples, and a constraint are given like task length can be up to 10 to power 4, and it's uppercase letter, and n can be 0 to 100, means gap between the two same consecutive tasks can be up to 100. Okay, so I have rather like written the same problem in Accelerator, so whiteboard, so you you can understand better. So let me explain first how we will attempting this task. Okay, so from time it start from one, right? If you see first thing, how will you find out the task, like how will you find out the like execution of the order of the task, so that minimum required interval, minimum required time in order to complete all tasks. Okay, so the target, what we need to we need to target minimum possible time to complete all task. Okay, so if you see the problem statement, uh task, different task with the labeled from A to Z. Okay, alphabetical, and can be repeated. Okay, so what we can, how we can attempt, if we have, think of, if we have attempt task A, task 1 at time is equal to 1. Let me put here at time is equal to 1. If I have attempt the task 1, then we can't attempt task 1 until the time difference between these two should be at least this number. Okay, so if I explain in simple way, if I have attempted task 1 at, let's suppose start with 1, then next eh, same task can be attempted. If you see time, like means 1 plus and 2, if you see this is 3, is this gives the 3, but we need a difference of n, right? Then we will need to add one more, right? Then it will give the 4, means time is equal to 4, which is current time, plus 2, which is n, if I replace, plus 1, that will, this is the formula. Next, time to attempt same task, right? This is the formula. If you see, next time to attempt the same task, which is the current time where we have attempted, plus n plus 1. If you apply this formula for n is equal to 2, this give the 4, right? And if you find out the difference between 1 and uh, what is the, find out the difference between these two, then what is the difference? If you see, uh, this attempted at t is equal to 1, right? Then let's leave it here as like idle time, and let me just idle time, okay, then again idle time, then attempted the task 1 again. I'm not filling task 1, just I'm explaining how it, what is saying, right? So if you see, this is equal to time is equal to 1, and if you see, this is at time is equal to 2, and this is at time is equal to 3, and this is time is equal to 4. So if you see, there is two gap between the same task. Okay, the time gap between the between same task, which is 2, right? 1 and 2, this is 2, not 4 minus 1, which is give the 3, that not 1. Gap is not different. The gap is saying like there will be a, like, if you see the problem statement, what is saying, right? It's saying at least an interval between the two tasks. This is the interval. It's saying interval means one interval is this one, the one interval this one, 2 and 3. This is two interval. Then two interval required to attain the same task. Okay. So if you see, but meanwhile, be, in order to minimize the possible time to complete all tasks between these two duration, CPU will be the ideal, right? Then we can utilize this idle time to execute another task, which is means a different task that satisfied the condition, right? We can put another task, right? We can put here B. If you, let me just replace with the task A and task A, then we can put here B, right? Just after completing task A, we can put B here, right? Then we can't, we have only two tasks, right? here. If you see, we have only two tasks, A and B. We can't put B again here, and B can't put A again, right? There at least an interval required. Then one idle, I am representing idle time as a has, then begin attempt there here, right? You see that time is equal to one task A completed, one instance of task A completed, time is equal to 2, one instant of task B completed, then time is equal to 3. CPU is ideal. No more task is available to complete at this time, right? So similarly, at time is equal to 3, task A, again we have one instance of like two instance remaining, right? Then we can attempt here. So similarly, we can attempt again B, because two consecutive B, we have two gap here. One is idle, one is execution of task A, right? Then again we need required a gap. Then we can again execute A and B, right? If you see any task between the same level, we have at least an gap, right? So we can execute that. If you calculate the total time from here, 1 2 3 4 5 6 7 8, the answer is total time required to complete it 8, right? So if you observe that, what you see, if you observe that a task which have maximum frequency means maximum instance, like if you see that, if you just remove this one, like we have let's just remove it. Total frequency means total instance of task A, we have 3, right? Total instance of task B, we have 2. Just I have just removed one. Let me just remove one instance of B to explain better. So if you see how, suppose we definitely know that if we have started with the task which have a higher frequency level, which have greater frequency level, we need to attempt first it, right? In order to finish in minimum possible time. If we start with the uh, task which have higher frequency, which is in this case which is A, then we can't attempt, right? We can't attempt task A until t is equal to 4, right? Then we have, let me just, time is equal to 1, then I have a 10 executing task A. Okay, after executing we have if we like maintaining the all task with the its frequency. If I attempt I have attempted like executing of in first one instance of task A, then remaining we have two instances, and we have also 2, right? And time is equal to 2. If you see that, we can we can't attempt we can't attempt task A again, right? Be required, we can execute again task A at time is equal to, if you apply that formula, we can execute task at time is equal to what is initial when it was attempted, time is equal to 1, right? 1 plus which is n plus 1, right? That is 4. Means at time is equal to 4, the next instance of A will be executed. Before this time, we can't execute that, right? Then we can utilize another task to execute in between there, there, in between time, right? Time is equal to 1 and time is equal to 4. We have two time, right? Time is equal to 2 and time is equal to 3. In between, in that time, we can attempt another task to utilize that CPU time and finish another task. Okay, so let me just think of the structure data, what the data structure exists that will give the like task which have higher frequency. Like if you see, we have a like priority queue, right? Priority queue. Suppose initially we will put all the frequency of task, then we will pop out the higher frequency and start executing, then put back again, then we need to find out again what will the max or what next max, right? So that is the priority queue. If you see, the priority queue on other data structure that can be utilized here. Okay, so let me just like write down the approach how we will proceed that in programmatic way. Okay, so so what I will do, let me just denote add a PQ is the denote the priority queue, and first I will calculate the frequency of each task. Okay, then I will put into uh, where I will put into, I will put into uh, a priority queue, right, where the priority order will be defined by the its frequency. Okay, that's matter. So this is the denoting the task A have frequency 3 and task B. Let me again put here with the same problem statement so that, okay, so we have a frequency 3 initially. Okay, what, let me uh, think here. Once you execute task, any task from priority queue, then we can't execute next, like current time plus n plus 1, right? Means if we have executed task A at time t1, then what will be next execution? Time t1 plus n plus 1, right? At this time, this task will be available to execute due to the constraint, right? So this, if you see, this is the cooldown period of task A. Means we can't execute task A in between the time. So we required another like data structure where we can maintain the cooldown period of task which is like executed just, and we after executing we will put into the cooldown period if we have like instance, we have like enough instance to get executed, right? So let me define the cooldown period. Cooldown queue, not period, cooldown queue, right? Cooldown queue. What is represent? It we will put uh, task after executing when we have more instance of same task with next execution time. Okay, this queue will tell us when the executed task will be available to execute. Okay, so let me define the CQ, cooldown queue. Okay, initially it will be empty, right? Initially, why it will be empty? Because we haven't executed any task. Okay, so let's start. Time is equal to 1, then at time is equal to 1, then I will execute the task A, right? uh, I put into a priority queue, it gives the maximum frequency, this one of these one, right? Either A, either B. Let me assume it will give the task A, right? So I will execute that first one instance of task A. After executing, we have remaining one instance, right? So in PQ, just remove from PQ. What will be the PQ after the time one? That will be the B, right? And it will have a instance 3 and have a CQ which have a I've just executed one, right? So it have a first it have a task, and we have a one instance has get executed, then remaining 3 minus 1 which is 2, and next execution time current time is 1. 1 plus this is 2 plus, means if you see current time is 1, right? 1 plus n, which is 2, that 3 plus 1, which is 4, right? Then time is equal to 2. Then we have no task available to execute, means no task available to put back into a queue. Then we will executing like task B, and just it get empty, and CQ will become the uh, A2 and 4, and B2, and it will be executed at time is equal to 5. If you apply the same formula, time is equal to 2 plus 2 plus 2 and plus 1, that is the 5, right? Similarly, so time is equal to 3, time is equal to 3, priority queue is empty, right? And we don't have an available any task to put back into a priority queue, right? If you see what is the available time of task A, that is 4, available time of task B, which is the 5, means if you see this is the increasing order, right? We are putting in, time will be always in increasing order. So this will be idle, no task will be executed, it will be as it is, just copy it. And time is equal to 4. Then at time is equal to 4, we will pop from here and put here. Once you put here, then we will again like pop out here and put, then again we will once it have a priority queue, then remove from here, uh, it become again like empty, and CQ become A and one instance of this task. And what is the time of this one, right? If you see what is the time instance of this one, uh 4 plus 2 plus 1, right? 7, right? It will be executed again at 7, and this will be executed at similarly, and B2 and 5, right? At time is equal to 5, if you see, so PQ become, once time is equal to 5, then first I will check what the available any if there any task in cooldown queue is available to execute, then this is the one, right? Then just put back, this is the queue, right? This will be appended here and not, and back and front, this will be this one, right? Then if you again, if you see again, we will pop out, right? From CQ, what it become, let me just copy here and put here from here and put here one instance with the time is equal to 8, right? And time is equal to 6, this will be idle, no task will be available. Time is equal to 7, one task will be available, then time is equal to 8, then it will require the time, total time 8, right? So let me write the algorithm for code for it, right? I have explained the problem. For any doubt, you can ask me in the comment box for any clarification for this problem. Meanwhile, I am just writing the code. Let me write. What I will first require, I require the to calculate this frequency, right? So I require the hash map, where this is the character, and I need an integer, and this will give the frequency of each character, new hash map. I'm writing code in Java, right? You can convert it into another language. You just need to understand the thought process, right? Okay, so I first need to require the frequency, right? Let me just iterate each task, which is the char, task, just iterate the task, and FREQ dot put task, FREQ dot get or default task 0 plus 1. That's just it is just syntax, right? To just calculate the frequency. Once I have calculated the frequency, I just first I will define the priority queue. Priority queue. Okay, so let me if you see in priority queue, I just need the frequency. I can keep the task with its frequency, but task level doesn't matter, right? It's matter only frequency. So I keep minimum one, right? What the minimalist? So I just keep the frequency integer and PQ and new uh, queue. If you see, in Java, priority queue by default is the min heap. I need the max priority queue. Then I need to reverse the order. So for that, I just define the lambda function a and b, and I need to just compare integer dot compare. I hope it b with the a, right? This give the max heap. Okay. So, okay, I have defined, I just need to put the frequency of the task, correct? So, so I think I need just what I need, put the value, right? So let me just for uh, map dot entry, let's iterate the hash map integer entry and entry set, right? Just need to put it have offer function, not put, right? So entry dot get value. Okay. So once we have put the into priority queue, let me define the cooldown queue. So queue, what I need a if we I just let me just comment here task frequency. Okay. So I need here in queue what I need. Let me first define. I need a frequency of task and next time to execute, next what time it will be available to execute, right? So it have a time, next time. So I need two element, right? So I can define the simple integer instead of defining the class where I can define these variable. Just keep it simple. So I need CQ, cooldown queue, right? I define the array, right? Array queue. Okay. So let me start the time. Int time is equal to 0, not 0 is equal to 1. Start from 1 while not is equal to pq dot is empty, or so either it should not be empty, either it will be empty, or mean either all task will be in a queue or in the cooldown period, right? So I need to check this also, right? If both are empty, then task will be completed, right? Empty. CQ dot not empty. And if this is not empty, what I need to do? Just TP. Just poll the pop. PQ dot poll. This give the frequency if frequent. Let me define it frequency for fr is greater than 1 means we have more than one instance of that task, then just put into cooldown period CQ, cooldown queue, which is have a offer similar to this one, and I need to put as form of array where the first element of the frequency, but I have executed one instance of this task, then frequency minus 1. And what will be the next time to execute? What is the current time? Plus n. What is the n is given? Plus 1. That the time it will be available to execute, right? Okay. And to the time plus 1. But one thing again, if while if, I think it's not empty and CQ dot peak, and what is the give the time, who is the second element, right? 1 is equal to time, then means it available to execute, then remove from here, put that into a priority queue so that it will be available to execute. Okay, so what I need to do? I need to do what I need to do, remove from here, right? Okay, PQ dot offer and CQ dot poll poll. I need first element, right? For this one, frequency. This is this correct, right? Okay, so I think in last just return the time. Let me run it first. Hopefully it will get executed. Let me just run it with the sample test case. Okay, this is what? Too frequently. Oops. Oops. Again, syntax error. Character. Is it? I hope so. Character. Oops. Again, converted into that's the this will be the same as the type of the hash map. Oops, again, wrong answer, which is give the 9 and required 8, 7, 8, 11, 12. Okay, got it. Okay, so in either way, if you see if it time is equal to t, if all the task is completed, I've just incremented it again, right? So instead of returning, I will need to return time plus 1, time minus 1. Okay, not plus 1. Okay, so I see it executed. Let me submit it. Hopefully it will be accepted. Yeah, that will be accepted. that is accepted. Okay, so um, I yeah, I think this is all about the if you see we can little bit we can more optimize this task. Think of the situation where the all the task put into the cooldown. No more task is in priority queue. Okay, and suppose let me just give the time, and let me time is equal to 2, and all the task I have put into executed and put into a priority in a cooldown queue, and first available task at will be, let's suppose, at time is equal to 4. That will be based of time. We are just going one by one, it like incrementing one by one time, right? We can just jump into the like first available task which in a cooldown queue, right? So how will we do that? Let me just put it here. Once it have it once means it is have a task, means priority queue have a task, just go one by one. Else, in case else means we don't have task in priority queue, all the task in cooldown queue. Then instead of going one by one, just go at the like uh, first one which can be available, which is the first element of the cooldown queue, right? So time is equal to update with this one, correct? Then we can jump in that time. Okay, so let me just run it. This is little bit more optimization in case of larger gaps. Okay, remove from here. Let me submit it. Okay, yeah, it's accepted. Let me just test with the all the test cases. Yeah, now it's better. Okay, one more optimization you can do. I'm not doing here, but I'm suggesting here. Instead of going like one by one iterating each, we are putting only frequency, right? If you see hash map value, whatever the value we are iterating and one by one putting. Instead of doing, just get the value, list of value and pass here. That will give the linear time instead of n log into n. So if you see what are the time complexity, so time complexity, if you see the total number of tasks, in any case you are not total number of tasks, it will be required. I think it will be hard to calculate the time complexity. uh, let me just going through, let me find out. If you see the time complexity of this one, that will be the total number of distinct uh, total number of tasks here, which is the if you see PO of n, which is the length of task, and here will be the distinct number of character, this number of character. So you are iterating only those, and if you see here, then it will be time required. I don't need to calculate that. This is the time we are calculating, right? If you see, that's the time, which will be the total execution time, right? One by one we are going, right? So that will give the big O of time. So what will be the maximum one? That will be the on average time complexity. So that's it. Yeah, I hope you understand it better. I picked this problem because I feel this is an interesting one. That's why I picked this. Again, I will pick next problem which will be I feel interesting at that can be possible to ask in interview. So I am not like anyhow I am not like picking any problem which is like more generous and can be available anywhere. So I am picking those which is I find more interesting, and like I find like I should like create a video on this that those lead code problem I generally picked. Okay, so that's it. Happy coding.